Single-piece flow is the practice of making one product at a time, moving it smoothly from one step to the next without delays or piles of work in between. Instead of producing large batches, you focus on a single unit, creating a continuous journey from raw material to finished good. This approach is a core principle of lean manufacturing, which aims to eliminate all forms of waste, time, materials, and effort that don't add value. Single-piece flow attacks the waste of waiting and excess inventory directly. By moving one item at a time, problems become instantly visible. If a machine breaks or a part is bad, the line stops and the issue is fixed immediately, making quality part of the process itself. Imagine making sandwiches. Batch production means buttering all the bread first, then adding filling, then assembling. Single-piece flow means making one complete sandwich at a time. With single-piece flow, you discover issues right away, like running out of filling on the first sandwich, not after prepping 10. This immediate feedback makes the system responsive and effective. The journey of single-piece flow is about seeing a factory as a stream of value, not just machines and people. Pioneers realized that the faster a product flows, the more efficient and profitable the business becomes. They challenged the belief that bigger batches were better, proving that focusing on one piece at a time could transform entire industries. Today, single-piece flow is recognized as a key driver of innovation and efficiency. It's not just a manufacturing technique, it's a mindset that changes how we approach work. The story of single-piece flow is the story of moving from cluttered, wasteful production to streamlined, value-driven processes. It's about making quality and efficiency inseparable. This video will explore how single-piece flow evolved from early factories to modern industry. We'll see how it revolutionized manufacturing and continues to shape the world today. Let's begin the journey from batch chaos to the power of flow. Before we continue, if you are enjoying this video, feel free to like, subscribe, and hit the notification bell to receive future updates. Before flow, factories used batch and queue production, making large quantities of parts at each stage, then letting them sit in piles, waiting for the next step. Workers or machines performed a single task on huge batches, creating long lines of idle inventory. The logic was simple. Set up a machine once, run it for a long time, and produce as many identical parts as possible before changing over. Departments were specialized: cutting, drilling, assembly, each focused only on its own output. The problems were hidden, but significant. Massive work-in-process inventory tied up capital and took up space. Quality issues were often discovered late, after hundreds of faulty parts had been made. Lead times were long, products spent most of their time waiting, not being worked on. Companies struggled to respond to changes in demand, stuck with huge inventories of the wrong parts. Batch production seemed efficient, but it was slow, inflexible, and wasteful. Most of a product's journey was spent sitting, not moving forward. This system made it hard to spot problems and even harder to fix them quickly. The result: factories full of parts but not enough finished goods. The batch and queue mindset dominated early manufacturing, but its limitations set the stage for a revolution. The need for speed, flexibility, and quality would drive innovators to seek a better way. The seeds of flow were about to be planted. The next step was to question the logic of isolated departments and endless queues. Change was coming. The move away from batch and queue began with simple observations. Piles of inventory weren't a sign of productivity, but of waste. Early thinkers wondered, what if work followed a sequence with the product dictating the layout, not the machines? The Venice Arsenal in the 15th century was an early example, using a canal-based assembly line to build ships faster. Though still batch-based, it showed the power of arranging work in a continuous sequence. The key insight: time and distance between steps are waste. Experimenting with layouts, some factories placed machines in process order, reducing travel and making flow visible. These were incremental improvements, not a full system. Technology limited progress. Machines were big, fixed, and hard to move. But the idea of flow was taking root. The true breakthrough would require new technology and a visionary to bring it all together. The stage was set for a revolution in manufacturing. Henry Ford transformed manufacturing by introducing the moving assembly line in 1913. His goal: make cars affordable for everyone by slashing production costs. Instead of workers moving to the car moved past stationary workers, each performing a simple task. This created a continuous, visible flow, and dictated the pace of work. Assembly time for a Model T dropped from over 12 hours to just 93 minutes. Ford's system arranged machines in process sequence and balanced workloads, creating a river of production. The result: mass production at unprecedented speed and cost. But Ford's flow was rigid, designed for one product, the Model T, with little variation. "Any color so long as it's black," he famously said. This lack of flexibility became a weakness as customer needs changed. Ford mastered flow for a single product, but the next leap would require handling variety and adaptability. The world was ready for a new approach, one that could combine flow with flexibility. That breakthrough would come from post-war Japan. The evolution of flow was far from over. After World War II, Toyota faced huge challenges: limited capital, a small market, and no room for waste. Eiji Toyoda and Taiichi Ohno studied Ford's lines but saw their limits. Ford's system couldn't handle variety. Toyota needed flexibility and efficiency. Ohno developed the Toyota Production System, focused on eliminating all forms of waste. Such waste is referred to as muda. The breakthrough in the new production system was the single-piece flow that was enabled by slashing machine changeover times using SMED, single-minute exchange of die. Changeovers that once took hours now took minutes, making small batches and even one-piece flow possible. Another innovation was Kanban, a visual system signaling when to produce more parts, creating a pull system based on real demand. Work was only done when needed, preventing overproduction and smoothing flow. The result: high quality, low inventory, and the ability to build many models efficiently. Toyota's system proved that flow and flexibility could coexist. This new approach would soon attract global attention. The world was about to learn the power of lean. For years, Toyota's methods were a Japanese secret, while Western factories stuck to mass production. The oil crisis of the 1970s changed everything. Suddenly, efficiency and flexibility mattered. Toyota's lean system delivered quality and variety at low cost, drawing worldwide attention. The 1990 book, The Machine That Changed the World, introduced lean production and single-piece flow to the West. Companies everywhere began rearranging factories into cells, U-shaped layouts where teams moved products through all steps without delay. This was single-piece flow in action, eliminating waste and boosting efficiency. Many struggled to copy the tools without embracing the philosophy of waste elimination and worker empowerment. True lean success required a cultural shift, not just new techniques. Those who committed reaped huge rewards in quality, speed, and profitability. Single-piece flow became a global standard for excellence. The revolution had gone worldwide. Single-piece flow delivers dramatic benefits. First, it slashes lead times, letting companies respond quickly to customer orders. Quality improves, as defects are caught immediately, not after hundreds of parts are made. Inventory shrinks, freeing up cash and factory space. The factory becomes cleaner, safer, and more organized. Productivity rises and employees are cross-trained, making work more engaging. Workers are empowered to stop the line and solve problems, building ownership and pride. Stress drops as chaos and firefighting disappear. The result: faster delivery, higher quality, and happier teams. Single-piece flow isn't just efficient, it transforms the entire workplace. It's a win for customers, workers, and the business. Today, single-piece flow shapes industries far beyond car factories. Aerospace, electronics, and even hospitals use flow principles to deliver value faster and with higher quality. Hospitals create care cells to treat patients without delays, reducing wait times and improving outcomes. In software, Agile and Scrum use visual boards to manage work in small, continuous increments. Single-piece flow for code. Modern factories use sensors and automation to keep flow smooth and spot bottlenecks instantly. Robots handle repetitive tasks, working alongside people in flexible cells. The core idea remains: eliminate delays, make value flow, and treat every interruption as waste. Flow is now a universal principle, not just a manufacturing trick. The tools evolve, but the goal is always smoother, faster, better value delivery. Single-piece flow is everywhere, and it's still changing the world. The story of single-piece flow is a shift from chaos to clarity, from waste to value. It began with the insight that waiting is waste, and grew into a global movement. Ford's assembly line showed the power of flow. Toyota perfected it with flexibility and quality. Today, flow is a strategic weapon, essential for survival in a fast, competitive world. Companies stuck in batch thinking are slow and burdened by hidden costs. Single-piece flow makes value creation transparent and forces real problem solving. It empowers employees and creates a culture of continuous improvement. The lesson: see your process as a stream of value, not isolated steps. Eliminate everything that interrupts flow. By moving one piece at a time, you unlock efficiency, quality, and customer delight. The power of flow can transform any enterprise, factory, hospital, or software teams. Thank you for watching. If you enjoyed this video, feel free to subscribe and hit the notification bell to receive future updates.